Moving fluid exerts forces on objects that it contacts with. These forces can be determined, as in solid mechanics, by the use of Newton's second law or the momentum equation. From this example, in the picture, the force exerted by a jet of fluid can be resolved by applying the momentum equation. The study of these forces is essential to the study of fluid mechanics and hydraulic machinery. So as you can see in the picture, in hydropower plants, turbines are utilized to generate electricity. Turbines rotate due to force exerted by water jets that are directed tangentially into the turbine's blade or buckets or vanes or anything. The impact of the water on the blade generates a torque on the wheel, causing it to rotate and to generate electricity. So it makes me wonder whether the shape of the blade plays any role in electric generation. So in this experiment, the objective is to investigate the reaction forces produced by the change in momentum of a fluid flow when a jet of water strikes a flat plate or a curved surface, and to compare the result from this experiment with the computed force by applying the momentum equation. So we have a theoretical value and an actual experiment value. The theoretical jet force is calculated from the principle of linear momentum, where I have included the formula on your screen. And the density of water is equal to 1 kg over meter cube. So in the case of flat plate, in this case, the angle would be 90 degree. And if we insert 90 degree to cos 90, it would be equal to 0. So in a flat plate case, that is the formula for F theoretical. And in the case of hemispheric cup, where the angle is 180 degree, I have if you input 180 to cos 180, it will equal to -1. And I have included the formula for hemispheric cup. Experiment is set up as shown in the picture. We have a nozzle, we have a target plate, and a weight. We try to keep the nozzle diameter constant, and the only thing that is changing is the target plate and the volume, since we have a flat surface and hemispherical shape. And the volume of water is from a range of 2, 3, 4, 5, 10, and 12 liters. Result of the experiment is as shown as in the figure. The theoretical value is from the formula that I have given earlier, and we could see that the error between F1 and F2 is equal to 0.168 for a flat plate, and the error between F1 and F2 for a hemispherical cup is 0.6981, which is significantly larger than flat plate. So here's the graph showing how significant is the error. So there is two conclusions that I would like to point out. Number one, as the volumetric rate of flow Q increased, the force resulted from the impact of the jet on both the flat plate and the hemispherical cup is increased to for the predicted F1 and the measured F2 values of the force. This relation can be seen clearly from the 4 plots accompanied with this report. This result was also predicted from one of the change in momentum equation of the calculating force. Second conclusion is, according to the last point, the hemispherical cup is more efficient for using in a turbine than a flat plate. But only one point to be considered is that the water to exit the cup is going to collide with water entering the cup, which will reduce the force for that reason. The cup is made in angle less than 180. So there is a lot of interference, and that is why the error in theoretical and experiment is significant.